TCP/IP concepts and configurations. In order for computers to communicate with each other on a computer network, they need to speak a common language. And in computer terminology, the common language is referred to as a protocol. And in this video, we're going to learn about the default protocol that's installed in Windows XP, which is the Transmission Control Protocol, Internet Protocol, or TCP/IP for short. In this video, we'll see how Windows XP communicates with other computers by using the TCP/IP protocol and by also using names to find computers. And then we'll look at how to actually provide an IP address to a Windows XP computer by using 3 different methods. Once our computer has all configured with the TCP/IP protocol, we'll learn a couple of methods for troubleshooting our network connections in case something goes bump in the night. So let's get started by seeing how Windows XP communicates with other computers by using the TCP/IP protocol. So in this diagram, we have several computers that all have the TCP/IP protocol installed. In order for the computers to communicate with each other with this protocol, each computer must have its own unique IP address, which is represented by this number of 192.168.1.10. And we can see that the last digit for each of these numbers is different. So each computer has its own unique IP address. And this process is very similar to using a telephone, where each person that wants to communicate by using a telephone must have their own unique telephone number. A telephone number is divided into 2 distinct pieces, an area code and the phone number. The area code defines which part of the country that we live in, and the phone number is our own unique number that rings our phone instead of our neighbor's phone. Well, similarly, an IP address is divided into 2 pieces called a network and a host. And in this example, the 2 pieces are divided right here. The 192.168.1 is our network, and the .10 is our host. And the network is the equivalent of our area code. It defines a logical grouping of computers, and this portion right here, host, is the equivalent of our phone number. It just uniquely defines our computer on the network. I was able to determine which part of the IP address is network and which part is host by using these numbers right here, which is called our default subnet mask. The 255.255.255 masks off which portion of the IP address is network and which portion is host. And these 3 255s are divided into areas called octets. And it's masking off the first 3 octets as network, and the 0 is representing that our last octet is our host. Let's talk about the octet here for a sec. An IP address is a 32-bit address which is separated by these 4 periods. Within each period are 8 bits, and this area is referred to as an octet. So the question that remains is, where do we get these IP addresses from? Do we just make them up out of thin air? Let's take a closer look at this. There's a governing body called the Internet Assigned Numbers Authority, and this authority provides the IP addresses to large companies, the government, and internet service providers out of these 3 classes. And the number in the first octet denotes which class an IP address belongs to. Class A IP address is identified by the range in the first octet of 1 to 126, and a Class A IP address only uses the first octet to denote its network, and that means it can create up to 126 networks, and that leaves 3 octets remaining for hosts, and that means that we can create over 16 million hosts on each of these 126 networks. In contrast, a Class B IP address is denoted by looking at the range of 128 to 191 in the first octet, and a Class B will also use the second octet for network, which means that in this situation we can create 16,384 networks, and we've got 2 octets remaining for creating hosts. So on each of these networks we can have 65,000 plus hosts on each of these networks here. And lastly, a Class C IP address is denoted by the range in the first octet of 192 to 223, and it uses the second and third octets for the network portion of the IP address, which means we can create over 2 million networks, and that leaves the 4th octet left over for hosts, and that means we can have 254 hosts on these 2 million plus networks. Now you might be thinking to yourself, well, I thought you just said a moment ago that the subnet mask identifies which portion of the IP address of the network, and now you're telling me that a class is telling me which portion of the IP address is the network. A subnet mask will always identify which portion of the IP address is network and which portion of the IP address is host. But we have two types of subnet mask, a default and a custom subnet mask. In our examples, we're talking about using a default subnet mask. And in a default, you're always using 255 to mask off which portion is network and host. For example, in a Class C, the default subnet mask would use 255 in the first, second, and third octet, whereas a Class B would use 255 in the first and second octet, and lastly a Class A would use 255 in the first octet to mask off the first octet as network and the remaining 3 octets as host. We can create a custom subnet mask to allow us a little more flexibility as to how many networks and hosts that we can create. And we go over creating a custom subnet mask in our Windows 2000 Exam Pack series. So we get an IP address out of the ranges from these 3 classes to uniquely identify our computer on a TCP IP network. However, here's the kicker. Most of these IP addresses have already been taken. The government, large companies, internet service providers pretty much have a lock on all the available IP addresses. So what does that leave for us? What IP addresses can we use within our home network or within our company networks? Well, thankfully, the Internet Assigned Numbers Authority have carved out a range of IP addresses within Class A, B, and C that can be used within networks that are not connected to the Internet. What I mean by that is if you were to configure a computer with an IP address from one of these 3 ranges and connect it directly to the Internet, that computer would not be able to communicate with other computers on the Internet because the routers on the Internet have been trained to filter out all requests coming from these 3 ranges. So these computers would have to access the Internet through a proxy server or a network address translation server that does have a direct connection to the Internet. So in our example, we had chosen IP addresses out of the 192.168 range. Let's go back and take a look at that. So we have 192.168.1 network, but we also have another network represented by 192.168.2. And we can see the IP addresses that have been assigned to our computer by using a command called IP configuration, or ipconfig for short. Let's take a look at that. ipconfig is run from the command prompt, so we open that up by clicking on Start, click on Run, type in CMD, press Enter. Poof, that opens up the command prompt, and from here we type in ipconfig, press the Enter key, and you see your basic IP configuration information. You see the IP address and the subnet mask that have been assigned to this computer. And a computer using TCP IP has to have an IP address and subnet mask. You can't leave home without it. But we can have optional IP addresses such as our default gateway. Let's talk a little more about that. Minimize this, go back to our slide. The IP address of the gateway is essentially a door to a whole nother world. And that whole other world is other networks that are available within your company, or the biggest network of all, the Internet. And we use a device called a router to access these other networks, and the router essentially joins multiple networks together to allow for cross-network communication, or essentially allow all networks to communicate as one network. The router will have several network interfaces, also known as network adapters, and these interfaces connect the various networks together, and each network interface will have its own unique IP address, and that will be the IP address of the gateway. So in this example, our router has 3 interfaces which join together our 3 different networks, and if we would like to allow the computer XP1 to go from its network of 192.168.1 out to the Internet, we would have to provide this computer with the IP address for the gateway of 192.168.1 because that is the network that this computer is on. So the question that remains is, how does the computer know that it's supposed to use the gateway in the first place to get from its network to other networks? Computers are able to determine that the destination computer that it's trying to reach is on its local network or on a remote network by comparing the network portion of its IP address to that of the destination computer. For example, if we want to connect from XP1 to XP3, we're going to use our subnet mask to find our network, which is right here, the 192.168.1, and we're going to compare our network to that of XP3, and we see that it's also on the 192.168.1 network as well. So in this case, we're not going to have to go through our gateway to get to XP3. In contrast, if XP1 is trying to access a computer at the IP address of 24.24.0.1 with a subnet mask of 255.255.0.0, we're comparing now the network of 192.168.1 with this difference right here. So we see an obvious difference in the network, which means now that in order for XP1 to connect to this computer, we're going to have to send that information through our assigned gateway in order to access that computer. So once the router receives the information at its appropriate gateway, or essentially its door into the router is going to look at the TCP IP packet that came from the computer, and the packet will contain information as to which network that it's trying to get to. So in this example, the router is going to see the computer is trying to get to 24.24 network, and the router has a table which lists all the gateways that it must use to get from one network to another network. So in this case, the router is going to have to pass this information out from its network out onto the internet to another router on the internet that can access this network and eventually get to the 24.24.0.1 computer. So even though the IP address for the gateway is an optional IP address, it's, as you see here, a very important IP address in order to allow your computers to access other computers and services that are available on computer networks. So we've assigned all of our computers a unique IP address. We've given them the IP address of the gateway so they can access computers on their network and remote networks. But out of all this, we have lots of IP addresses, lots of numbers, and it's very difficult to try to memorize the IP addresses of all the machines in your network. Well, thankfully, we can also identify our computers with names in addition to our numbers. So for example, now when we want to connect to the computer at 192.168.1.10, we can connect to it by referencing its name, which in this example is XP1. There are two types of names that we can use to identify a Windows XP computer by. Let's take a closer look at this. There are host names and there are NetBIOS names. A host name identifies a computer as a TCP IP host on a TCP IP network, whereas a NetBIOS name identifies a computer that uses NetBIOS over TCP IP as a means to communicate with other computers and applications. This is a naming convention that's widely used by earlier Windows operating systems such as Windows 95, Windows 98, and Windows NT. In contrast, Windows 2000 and Windows XP are as a default referenced by their host names instead of NetBIOS names. The host name can be up to 63 characters in length, but in contrast, the NetBIOS name of the computer can only be 15 characters in length, and starting with Windows 2000 and Windows XP, the actual NetBIOS name is derived from the host name. We can see both name types that have been assigned to a computer by using the System Properties control panel. We can access that by clicking on Start, selecting My Computer, right-click My Computer, and then choose Properties. And then from here, click on the Computer Name tab. So in addition to having a computer name in Windows XP, we can also have a description of the computer. And you see an example of that right here. This option is typically used for computers in a home network rather than a business network. To see the computer name, we click on the Change button. And the computer name and the host name are one and the same. So here my computer name is Nugget1. And to see the NetBIOS name, you would click on the More button. And so we see in this field, here's the NetBIOS name. And the NetBIOS name is derived from the first 15 characters of the computer name. But if you notice here, I can't change the name. I can't independently configure the NetBIOS name. This is grayed out. So I can't call the NetBIOS name Nugget2 and the computer name Nugget1. We did have that capability in NT, but that changed in Windows 2000, and Windows XP. So let's close out of here and go back to our slide. Well, names are all well and good, but referencing computers by names solves one problem, but it actually creates another problem. The problem that it solves is we don't have to memorize all these numbers, but the problem that it creates is that we have to reference these names to their IP addresses. So remember, we have to resolve the computer name to its actual given IP address, and we have two methods to do that. We can use just a file that contains a listing of the computer's name and its IP address, or we can use network services that take care of that work for us. Let's take a look at the files first, and they're found on our operating system partition. So let's first click on Start, go to My Computer, open up our C partition, and from here we're going to our Windows directory, and from here we're going to System32, and then from here we're scrolling down and looking for a directory called Drivers. And here we're looking for the folder called etc. And I've got the file path displayed right here in the address bar. These are all default files. You don't have to add these in. The operating system automatically places these files here during the installation. This is pretty straightforward. The host file contains a listing of the host names and their IP addresses. So what you could do, if you so chose, is to go into this file and manually add the IP address and the host name of every single computer in your network. Sounds like a barrel of fun, huh? I don't think so. The NetBIOS alternative to this file is right here. It's called lmhost, short for LAN manager hosts. And to actually use this, you would have to remove the extension of .sam. .sam is meant for a sample file. But for the computer to actually use and recognize this file, make sure you remove that extension. So if we double click this file, open it up with Notepad, take a peek in here, very similar to our host file where it has a listing of the computer's IP address and the computer's NetBIOS name. So once again, you would have to populate this file with every single IP address and every single NetBIOS name if you wanted to reference computers that way. Well, there's an alternative to manually updating and configuring these files. Let's take a look at that alternative. So let's bring up our original slide and take a look at this. Let's say, for example, the host XP1 wants to communicate with the host XP3. Well, XP1 could look in its local host file and see if there's a listing for XP3 and its associated IP address. If there's no listing for XP3 in its host file, another method that XP1 has to try to initiate communication with XP3 is by using something called a broadcast. And a broadcast is essentially a cry for help. It's just going to scream out in the network and say, hey, does any computer out there on my local network know of XP3 and your IP address? So every computer on this local network has to listen to this information and determine, are they XP3? Am I the person that they're trying to connect to? It's very similar to standing on the front porch of your house and screaming out to your neighbors, hey, does anybody know the telephone number for Bill? Well, somebody might respond, they may not respond, or they might throw something at you. Also, this broadcast, this cry for help, can only be heard by so many people. Your scream down to your neighbors only goes so far. So this broadcast is not routable. It's not going to be heard on our other networks. So instead of shouting out this broadcast to all of your neighbors on your network to trying to find a host, we have a more efficient method for trying to resolve a name to the number using dedicated services. Windows NT, Windows 2000, and Windows.NET servers have services devoted to resolving NetBIOS and host names to their IP addresses. The service that's used to resolve NetBIOS names is called the Windows Internet Name Service, or WINS for short, and the service that's used to resolve host names is called DNS, or Domain Name Service. And in order for the computers to reference and locate these servers running these services, you would have to provide the clients with the IP address of the servers running WINS and running DNS. And we can see that by using our ipconfig command. So let's bring up our command prompt that we have minimized down the taskbar. And earlier we ran ipconfig and we just saw the computer's IP address, subnet mask, and gateway. But if we type in ipconfig with a switch called all, press our enter key, we can see every single TCP IP address that was assigned to this computer. So in this case, we see the IP address of the DHCP server, which we'll talk about in a moment, the IP address of the DNS server, and the IP address of the Win server. So now that our computer is configured with the IP address of the DNS server and the IP address of the Win server, whenever we need to contact a computer by a NetBIOS name or a host name, we can contact these servers directly to try to resolve a name to the number. Let me show you what I mean here. So let's say, for example, that the computer XP1 wants to communicate with the computer XP4 by a NetBIOS name. Well, now that XP1 has the IP address of the Win server and the IP address of the gateway, XP1 can go through the router, go down to the Win server, and ask the Win server, Mr. Win server, do you have a listing in your database for the NetBIOS name of XP4 and its IP address? The Win server will look in its database, return that information to XP1. XP1 will then be able to go directly to XP4 without having to send a broadcast to all of its neighbors and bugging them, without having to look at its local LM host file and trying to maintain and update that file on a regular basis. So the only thing we have to be concerned with now in this environment is that the Win server always stays up, and number two, that we have the right IP address for our Win server. The computer uses essentially the same type of process when trying to resolve host names. So if we wanted to contact the host name of XP4, we would go through the gateway, through the router, and this time go to the DNS server, and the DNS server would look in its database to see if it has the host name of XP4 and IP address, return that information back to the computer, and then the computer would go directly to the host of XP4 instead of using a broadcast or instead of using the host file. However, we have an added dimension when we're trying to resolve host names to IP addresses, and that is we have to know the domain in which a host belongs. A domain is like Microsoft.com or CBTNuggets.com. When you combine a host name with the domain name, you derive what's called a fully qualified domain name. Let me show you what I mean by that. In this example, we have a host name called Nugget1 within the domain nuggetlab.com. And those two pieces combine together to form what's called a fully qualified domain name, or FQDN. Now, the key thing about all this is that you have to find the domain in which the host resides before you can resolve the name to the IP address. And so fully qualified domain names are resolved right to left. We're going to find the domain first. Then once we've found the domain, we'll complete the task of finding the host and its equivalent IP address. So let's bring up another slide and take a look at this. So for example, if we're in this company called TL Technology within the domain tltechnology.net, and we want to view a web page hosted on the host called www in the domain called cbtnuggets.com, what we're going to do is resolve from right to left. We need to find the domain first, cbtnuggets.com, and then the host within that domain. So the first step is we're going to ask our local DNS server, do you know where cbtnuggets.com is? And our local DNS server is going to say, hey, you know what? I am not the owner of that name. I have no idea where that domain is, let alone where www in that domain is. But this is what I'm going to do for you. This DNS server is going to go out to the internet to a DNS server called the root level DNS server and ask on behalf of the client the same question. Mr. Root level DNS server, do you know where the cbtnuggets.com domain is? And within that domain, do you know where the host www is? And it's going to respond back, what are you kidding? No, I don't know that information. But this is what I do know. I know where the .com domain is. So it'll get the IP address of the .com domain, and the DNS server will come back over here, contact a DNS server in .com. It's going to essentially reiterate the question again. Mr. .com DNS server, do you know where the domain cbtnuggets.com is? And in that domain, do you know where the host www is? Well, .com will say, you know what, you're getting warmer. I know where cbtnuggets.com is, but I don't know where www in cbtnuggets.com is. Well, thank you very much. That helps. So it gets the IP address of cbtnuggets.com. The DNS server goes to the DNS server in cbtnuggets.com. Ask the question again, Mr. cbtnuggets.com DNS server, do you know where the host www in cbtnuggets.com domain is? And it'll respond back, you know what, you came to the right place. I own this name, and let me look through the list. Yep, I have a listing for www hostname, and here's its IP address. That's given to the DNS server, which in turn is given to the client, which in turn goes out to the internet and finally contacts the web server and displays its web page. So this whole process is one of the reasons why it can take so long for a web page to appear in your web browser. Now the final question that remains is, how do our host names get populated into DNS servers, and how do our NetBIOS names get populated into Win servers? Well, to answer that question, let's go back to our original slide. Let's start with NetBIOS names. Because we've supplied all of our computers with the IP address of the Win server, not only can they reference the Win server to resolve NetBIOS names to computer names, but these computers will automatically try to register their NetBIOS name and their IP address with the Win server. So it's a dynamic process. The computer boots up, it says, Mr. Win server, here's my name, here's my TCP IP address, please add it to your database. And if the name doesn't already exist in the database, it'll automatically be added. The DNS server can work in this fashion as well. Windows 2000 and Windows.NET DNS servers can be configured for dynamic updates. And what that means is Windows XP computer that has the IP address of a DNS server that's configured for dynamic updates will automatically try to register its host name and its IP address within the domain that's on the DNS server. So you don't have to manually enter in the host name and the IP address in the DNS server, and you don't have to manually enter in the NetBIOS name and the IP addresses on the Win servers. They're just dynamically registered when the computer starts or when changes take place to the names and the IP addresses. Windows 2000 and Windows XP computers will only dynamically register their host names with DNS if two things are set up. Number one, DNS is configured to accept dynamic updates, and number two, Windows XP is configured to register their address dynamically. Let me show you how you do that. To view that information, we have to go to our network properties, and we access those properties by clicking on Start. Select Control Panel. From Control Panel, we're going to Network Connections. Double click on that. Select your network connection. Double click on that. Click on Properties. Select IP, TCP IP protocol. Then click on Properties. And lastly, click on Advanced. And then from here, click on the DNS tab. A little bit of a hike, but well worth it. At the very, very bottom here, this option controls that whole kit and caboodle. You have to make sure that register this connection's address in DNS is selected in order for Windows XP to automatically register its host name and its IP address within a dynamically configured DNS server. Which brings us to how do we actually assign an IP address to a Windows XP computer. There are two methods to assign an IP address to a computer. Manually, you just type in the IP address, subnet mask, and other IP addresses, or just automatically obtain the IP address from what's called a DHCP server, Dynamic Host Allocation Protocol server. And this is the default configuration for Windows XP. Automatically obtain an IP address, and what you don't see here is from a DHCP server. So when the computer boots up, it'll ask a DHCP server for an IP address, subnet mask, and optionally the DHCP server could provide the IP address of the gateway, DNS server, Win server, and other IP addresses as well. If the DHCP server is not responding to the client, the Windows XP client can automatically assign itself its own IP address through something called an alternate configuration. Let's take a look at that. If Windows XP has been configured to obtain an IP address automatically from a DHCP server, then you'll see this tab right here, Alternate Configuration. If you've manually typed in an IP address, this tab will not appear. And the Windows XP computer can automatically assign two different types of IP addresses if it cannot contact a DHCP server when the computer boots up. One is an automatic private IP address, also referred to as IPIPA, or an IP address that you define. Let's talk about IPIPA first. So with this option selected and Windows XP boots up and it can't contact a DHCP server within 60 seconds, what's going to happen is the Windows XP computer will automatically assign itself an IP address from this range that Microsoft had set aside from the Internet Assigned Numbers Authority. And this is not new. This technology has been around since Windows 98 and Windows Millennium, but we have a little new twist on it in Windows XP. So if you're trying to troubleshoot why your computer can't connect to other computers, maybe it just could not contact the DHCP server, and if you bring up the command prompt and type in ipconfig to see if you have an IP address from this range. So let's take a look at how the computers assign this IP address by stopping DHCP and see what we get. So I stopped the DHCP server service on my Windows 2000 server. So let's bring up our command prompt now and try to get a new IP address, and we can do that by using the ipconfig command. The first command that we're going to use is release. We're going to release our old IP address, and this is a handy command to use when you're taking your laptop and moving from one network to another. You can release your old IP address, and then when you plug your laptop into the new network, you would type in ipconfig renew to get a brand new IP address. And let's see how we do that right now. We'll type in ipconfig with the renew switch. So this will give us a new IP address and any DHCP scope options that might be available as well. A scope option contains optional IP addresses such as the IP address of our default gateway, IP address of our WINS and DNS servers. So let's press the enter key on our keyboard and see what IP address we get. And we should get an IPIPA address. And so it's trying to contact a DHCP server. It can take up to a minute before it times and fails out and says, oh, forget it, I'm going to use an IPIPA address. So it's just going here and going and going. And I'm going to pause the video and let it come up with the IPIPA address, and we'll come back up once it's found it. So let's start back up. It finally timed out trying to contact the DHCP server, which is what we wanted. So now when we type in ipconfig, we should see the IPIPA address, and here we do 169.254.157.36. So this feature was designed so that Windows XP computers would just automatically assign itself its own IP address. Because Windows XP is automatically configured to obtain an IP address from a DHCP server, if it can't contact a DHCP server, it'll automatically get an IP address. And this feature was really meant more for home users to connect to a home network where they just plug in their computers, they start it up, and they automatically have an IP address with no fuss or no muss. So automatic private IP addressing has been around since Windows 98. However, this feature has typically caused some fuss and muss on corporate networks where all of a sudden you can't communicate to other computers because you still have this IP address. And people don't know that they need to issue the ipconfig release or renew command or restart the computers once the DHCP server is back up in the network so they can get an IP address for their network. So an option that's been added to Windows XP is to provide a user-defined alternate configuration when a DHCP server is not available. Let's take a look at that by bringing up our properties. So this new option is really handy for laptop users that might move from a corporate network where they had obtained an IP address from a DHCP server to a satellite or a home office network where they don't have a DHCP server, but you'd like to give them an IP address automatically without the end user having to enter in all this stuff each time they go home. So we just click on the radio button for user configured, type in the IP address that they need in their alternate area, wherever that might be, home, let's say 168, okay, helps if I can type here, 168, .1 and how about .70. Press the tab key that automatically populates the subnet mask. Let's type in our default gateway 168.1.1, and if we have a DNS server, put in that information as well. And if we have a Win server, we'd type in that information as well to allow for our host and NetBIOS name resolution. And we'll click on OK. So when I click on close, it's actually going to have a little bit of a delay here. What's going to happen is the operating system is automatically trying to register this user configured information. So when I click on close, when we bring up our command prompt, we should see that user defined IP address right away. So let's test that out. So if we were to type in ipconfig and use the all switch, we should see all the user information that we just configured. Press enter, and indeed we do. We see the 192.168.1.70 and all the optional IP addresses that we just typed in as well. This is pretty cool stuff that we've got here in Windows XP. So while we're here, let's take a look at the rest of the commands we can use with ipconfig. And we can see all those commands listed out by using the help switch, which is just the question mark. And let me just scroll up here a little bit to see those switches, which are right here. So we've talked about how to use ipconfig with the all, the release, and the renew switch. The flush DNS switch allows us to flush out the DNS resolver cache. Now let's talk about that for a second. When your Windows XP computer contacts a DNS server to resolve a fully qualified domain name, the host and the domain it's in, such as when you're cruising the internet and you want to resolve www.cbtnuggets.com to its IP address, Windows XP will store that information that it got from the DNS server in what's called a local DNS resolver cache. And the benefit of having this cache is twofold. The next time the Windows XP computer wants to go to www.cbtnuggets.com, it's not going to query the DNS server first. It's going to look to its DNS cache first to see if it has a listing for that website. And if it finds that listing, it'll have the IP address and it'll automatically go to that website instead of having to bother the DNS server. The second benefit is it reduces network traffic of having to contact the DNS server all the time whenever it needs to query a fully qualified domain name. The negative aspect of using the DNS resolver cache is that the cache stores the positive results, meaning that it was able to find the website you're trying to get to, and the negative results, meaning that no, that host name that you typed in, I could not find the computer at that TCP IP address using that host name, and it stores that information in the cache, and that's where you get the rub. So if a negative entry is found in the DNS resolver cache, the computer will not query DNS to get an updated host to IP address mapping until the entry is either automatically flushed out from the DNS cache or you manually flush out the cache. And it can take up to 5 minutes for the entry to flush itself out from cache. So you could be pulling out your hair for the next 5 minutes trying to get to a computer that you know you've typed in the right name, but you've just got the wrong IP address cached in your machine. So let's use the display DNS switch to take a look at our cache, and then we'll use the flush DNS switch to flush this stuff out. So let's just scroll down a little bit to get to our command prompt so we can type in our command, which is ipconfig with the display DNS switch. Press our enter key. And so we see here we've got a fair amount of information that's cached in our local client resolver cache, some internal locations, some external DNS servers that we see here. So we want to flush all this information out. We're going to do that by typing in ipconfig with the flush DNS switch. I'm going to flush this client resolver cache right out of my hair. Press the enter key and poof, it's gone, just like that. Let's take a look at one more switch that we can use with ipconfig. Remember just a second ago we looked at how we can enable Windows XP to automatically register its host name and its IP address with DNS if we have this checkbox enabled. Well, if that option is not enabled, we can use a command with ipconfig to manually force the registration of our host name and our IP address by using the register DNS switch. So we press our enter key, and that forces our host name and our IP address mapping of this computer into DNS, and we're all set. Let's take a look at some utilities that we can use for troubleshooting our network connections with. The first command is called the ping command, and we can use this to see if a computer is up and running on the network, and we can ping either by a host name or an IP address. So if I type in, for example, a nugget 2, that'll actually ping the host name, so it's going to try to contact the DNS server and find this computer. And a ping is kind of like a sonar in submarines. It's pinging against the computer, and then we get this replying, this kind of echoing back, saying, yes, I'm here, and this is how long it took me to respond. So we use this just to make sure the computer is up and running, and to help us gauge whether or not the computer is responding by names and by TCP IP addresses. Windows XP also includes a NetBIOS name cache, so in addition to having a DNS resolver cache, we also cache all of the NetBIOS names and their equivalent IP addresses, and we can see that information by typing in nbt stat-c to look at that cache. So we see our NetBIOS names and the IP addresses associated with those names, and we can purge that cache, very similar to using the IP config with the flush DNS switch, by using uppercase R, press our enter key, and it purges it out. So now if we type in nbt stat-c, those entries are no longer there. If you're curious to see the network connections that are being made to your Windows XP computer, to see if somebody's trying to hack into your computer or somebody's remotely running something on your computer, you can use the command called netstat with the A switch, and that will display all the sessions, all the active sessions that are currently connected and running on your computer via the TCP protocol and the UDP protocol. And we talk about the differences in those protocols in our Windows 2000 Exam Pack series. So we see that Hotmail has connected to my computer using the TCP protocol at port 1933. We talked about ports in our remote assistance video earlier in this series. But what you would do is go through this list to look to see if there's anything foreign, and it shouldn't be here. And Windows XP includes a new switch for netstat to assist you with that. And that new switch is, let's type in netstat-aon. And now the additional information that we get displayed that we didn't have before is the process identifier that's associated with what's being connected to our computer. So from here we see that connections are being made to a specific IP address and a specific port number on our computer, but it's very hard to determine what application is actually making that connection. Well, using the switch that we just used, the -AON switch, that displays the processor identifier information, which in turn can be used to find out exactly which application is making this connection. And we do that by bringing up our task manager. So let's right click on our taskbar, bring up task manager, go to the processes tab, and then from here go to view, choose select column, choose process identifier, click on OK, and then you would scroll through this column and find the process identifier in our command prompt window from our netstat command, and then go into task manager and find that same process identifier and see exactly which executable is making that connection. So if we see a strange executable, a strange application, maybe there's a virus or some type of remote application that's trying to run on our computer that should not be running on our computer. So we can end the process of that task and use our antivirus program to try to eradicate that executable. So that completes our tour of some of the critical network utilities. Let's go back to our network connection to view some of the new features that Windows XP has to offer. We've got that minimized down on our taskbar, so we'll select that, click on Network Connections, brings up our Network Connections folder. So let's scroll down and find our network connection, which is all the way at the bottom here. And on the left hand side we see what's called a task view, and we see tasks associated with what we've clicked on. So when I click on this icon right here, the tasks change. When I click on my local area connection, the tasks change as well. So I can select my connection, rename it, repair it, we'll talk about that in a second, disable the network connection, view the status information, create a new connection from here. And if we scroll down, we can also see graphically what our IP address is, what our subnet mask is, and we can also see some of this information just by double clicking on the local area connection. Let's do that now. So this interface is very similar to Windows 2000, where we see our network connection speed, how long we've been connected for. But a new tab in Windows XP is right here, the Support tab. Let's take a look at that. So from the Support tab, we see the IP address information that you would see when you issue the IP config command, but we can see more IP address information by clicking on the Details button. And here we get tons of IP address information. It's essentially the same information that you get if you issued IP config with the all switch. We've got the address of our DNS server, Win server, our gateway, even the unique ID for our media access control number, or MAC address, which is the unique number that's burned onto our network card. And another feature that's new to Windows XP is this repair button. When you click on the repair button, Windows XP will attempt to repair typical network connection problems by automatically issuing the IP config with the renew switch, the flush DNS switch, the register DNS switch. It will also flush the NetBIOS name cache. It's going to re-register the computer's NetBIOS name with WINS, and it does all of this with the click of a button. You gotta love it when technology actually saves you time. Speaking of time, that brings us to the end of this video. Let's close out of here, bring up our slide. In this video we learned the concepts of TCP IP addressing and how our computer resolves NetBIOS names and host names. And we learned how to assign an IP address to our computer using dynamic, manual, and alternate IP address configuration methods. And then we learned how to use our different command line utilities such as ipconfig, ping, mbtstat, netstat to help troubleshoot our network connections. And then we finished off by seeing how a lot of those ipconfig switches are all integrated right into a repair button to give us a central location to perform a lot of network troubleshooting right from the click of the button. So I hope this video has been informative for you, and I'd like to thank you for viewing.